Um, the purpose of these lectures, mine and also from our guest lecturers, you have seen two guest lectures thus far, and two more, maybe another one edition, is to introduce you to how the water was being used as a source of life and agriculture and also culture in general sense from ancient time to now. Okay. And the course is to uh, how do we take learning from ancient time and apply new technologies that we are using or under current development to create a system together that could, through your design in second part of this class, that could help to cool city and urban environments. Okay. And the reason why that we are showing the ancient system was because the system was before we started using mechanical devices and pollutant energy sources such as especially fossil fuel, but not limited to, um, prior to, and that new technology machines together working with old, let's say, lack of a better word, natural environmental ways, maybe could bring an improvement to current standards and much more lead toward a sustainable and environmental urban life and spaces toward the future and save ourselves from global catastrophes, environmental catastrophes, crisis that we are already experiencing from COVID-19. Okay, so I will continue. So here's, you showed that the majority shafts were closed already in Roman times. In other words, that they were, uh, as a Roman Empire was beginning to shrink and recede, they were being abandoned already, so as to prevent objects and animals from falling inside. They start to cover them up, or even in modern times, completely close it with, you know, concrete poured into especially to the shafts. But you can see in this illustration, in the hydraulic structure of Dalmatia, that a lift uh, 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 was a kind of a mechanical construction that was most probably operated by human strength, turning them around to lift on what do you call it, pulley system, and the lift debris that are coming from the digging of the hole, and to be able to climb up and down. In fact, you see little niches under the side of the shaft that acts as a ladder. So it's a kind of like a reverse of a palm tree climbing, or a tall tree climbing by, let's say, uh, uh, uncivilized people that who climb up to gather fruit or eatables from top of the trees. Okay. And then again, on the bottom right side is a section of the tunnel. I have no idea why. This is I can't find the mouse. This is a problem of like different applications between keynotes of Apple and Zoom not working together yet. So you can see the section where the letter R is, you see the section that would be, I would imagine, maybe was made of stone, cut into in the shape of what looks like a kind of a U shape, letter U. which channels the water. The angle view at both left and right side is to kind of contain the water down. And then the U section at the bottom is where the water flows, giving them more, let's say, dynamics forces for water to, and this is very typical, even in, if you see the drainage, storm drainage in Los Angeles area, like LA River, for example, giant canal made out of concrete. You see at the middle of it what looked like a little channel to further help to drain the water, okay, or to capture water into a more concentrated line, shall I say. So again, here is sometimes the tunnels did have staircases. As you saw in Mr. Valentino's presentation, an old well underneath current building that has been hidden or destroyed. People used to walk down stairs to the well to get water. Here's another section in the middle showing that the same thing. The top curvature is the elevation of the land, and the horizontal line that shows here looks like kind of a tunnel is where the water flows, and all the vertical holes through the land is the shaft for moving materials, people, and giving air up and down the underground aqueduct tunnel. And I'm sorry that I'm not giving you any time to ask questions, but if you have any questions, please let me know through chat, or you can just audio interrupt me. And you can see all these various shapes, variations of the section of the underground tunnels that were built throughout Roman Empire. Quite a variety. All of these were kind of a design to maybe improve efficiency of water flow, thinking that different shape might make the water flow faster, or that this kind of shape of opening would be structurally more sound from caving in, failing, or even in the case of earthquakes that could withstand external forces better. So these are really a structural diagram. And this is something that you have to kind of remember and think about using in your design on the second half of this course. Piraeus is a major port in Greece, in ancient Greece time, 2,000 years or more. It still is one of the largest port in Europe. In fact, it's a part of the Chinese New Silk Road. I think they actually practically bought this port. And this is a map of contemporary map of the city and its port. As you can see that that there are these kind of, I'm sorry that I don't have the, but kind of cavities on the plan is where the water, where the port is, where the ships comes in. Some of the things that look like kind of like thin lines sticking out are breakwaters to protect the harbor from storms. Black dots are where that ancient wells, 330 ancient wells and 388 cisterns were found. And there's one line, dark line, that is underground tunnel. Okay, and these were discovered when the city was building, trying to build an extension to underground railway, which means a subway, basically, right? And there's a legend underneath the map that explains you what they are. The thinner black lines around the city was probably an ancient wall or city wall. And then the bottom is, you see, again, a section of the city. Somewhere it doesn't show where the sections were cut. It's basically cutting the city in half, so to speak. And as you see, in the top of it is houses. And underneath, you see all kinds of holes that are dug into the ground. Some of the straight ones are actually a well that reaches to the limit to the water table, which is indicated in horizontal dotted line here. And that's where the top of the water line, the water aquifers below the ground, and you have to get all the way down there in order to get to the water. And from that point, you have to bring it out, right? And then others that are much more larger, looks like a shape of a vase, is actually cistern, where once water is brought up from the source, it could be put in there as a storage for more consistent use in case there's no water underground. You have some saved to use until water returns. And some of the cistern might have been also at the same time getting water as well. And those would be the cisterns, kind of vase-like shape with some horizontal extension that may be where the source of water was. And then this section shows that the ground surfaces and the tunnel below to channel the water. And the left side and the top image would be where the water source is. Let's say maybe, in this case, maybe a spring. Or then you see the water table, the thinner line between the ground surface and tunnel. So in a sense, where you dig a tunnel, and 1/3 of the tunnel that is on the left side of the image is tunnel that collects water. Okay, so it has long length where water comes from the ground, and tunnel basically sucks water, and then it takes the water. 2/3 of it is no longer getting water, but it is just used to deliver the water to this destination on the right side. Now, on the top, why was tunnel this kind of more inclined tunnel, sloped tunnel is built? That was probably built to access into the tunnel or to dig the tunnel and to maintenance of tunnel. I think what is not shown is vertical shaft. And it may be so that in some cases that they did not use vertical shafts, okay? But in the Islamic world, a vertical shaft is always present. Even in Egypt, the famous Giza pyramid sites, they were channels built to draw the water from the Nile's river in your image on the right side. enormous underground cavern, a size of a football field. In this case, football field is not American football field, it's soccer field, which is even bigger, maybe more than 2 or 3 times bigger than American football field, was built underneath the pyramid to hold water. And here's a Google map of today showing that view from above, you see the 2 pyramids. And again, I don't have the mouse. So on the left side and the right side looks like kind of gridded areas with some cases with hole punched in them. These were a series of cisterns to hold water as well. And here is a deep hole in the pyramid site, connection to underground horizontal passages. These are Roman cisterns in the city, a great city of Alexandria, which is actually in Egypt, on the Mediterranean coast, west of Cairo, that you might know from the Arab Spring, Tahrir Square. That's where Tahrir Square is in Egypt. Okay, and in fact, Romans built. This is on the left side is a section of a large cistern that was 3 floors high. You can see the columns and the arches, semicircular arches that spans the ceilings between the 2 columns. As you can see on the 3rd column, it goes up to a hole above the ground to get air, maybe even light. And on the image on the right, you see similar kind of a system in a temple called Horus, where you see a structure that looks like a typical building, but it was not interior of a building, but it was not built for a human use occupation, but it was used to hold water underground. Reservoir would be a good word to use here, to supply water to the cities. Now, when we go to in the world, in the Arab world, in the case of Providence or the city of Yazd in Iran, or some Americans would say Iran, like I run scared or something. And these are the shafts that were built. And you can see the drawings on the right top, a man standing, turning what looks like kind of something that you would use to turn a yarn for making cloth, is raising and lowering a basket that takes the materials that were dug out, and you can see in the picture there as well. And it's operated by human. Okay. And it's a kind of a sophisticated pulley system in ancient period, and you can see a man, there's actually 3 men down below digging holes. And then in the very, very far right, you see another hole is being dug by another person, a shaft going down, not completed yet, meaning that, as I explained before, these holes were not only built to access down below, but it was also to build simultaneously, so it could be built, the tunnel could be built much faster. And as a result, at the other end, you could have something like this, where the water is delivered through an opening. And this is in a National Library of Iran in the capital city of Tehran, the heart of the what we call the evil empire. Now, why was this system developed? Of course, everybody needed water, but why this horizontally, gently declining, sloping down underground or open above ground channel was used to direct water from the source to the destination using the gravity, that is, gravity, right? Without using what we use as electric, steam, oil, other kind of supply energy machines to mechanically pump water from one place to another. In ancient period, when they didn't have any of these wonderful devices that we have now, they had to rely on nature, the gravity force. And where did they learn that? Also from the nature. And the physical structure of so-called the Qanats system, or Qanats, K-A-R-E-T-Z. There are 10 different names for this system, depending on which country and language that you are using. So, but for now, we will use Q-A-N-A-T or K-A-R-E-T-Z, Qanat or Qanats system. And it was learned basically from the nature. Many of the great alluvial fans, this one is in Afghanistan, another place where we Americans have enemies. Okay, sorry that I'm showing these enemy territories for your hydraulic spec design education here, but well, this is where they are at. And so you see the green area is basically, this is a huge scale. I don't really know how big it is because I don't have a scale, but from the top to bottom, it could be anywhere between 100 miles, 200 miles, maybe even more, like a satellite picture. So the green area is all the farms. And you can see where the water is coming from. Small river that you can see at the bottom of the picture. But that is not the only place. You will see, if you look closely later, that there are smaller alluvial fans that are dry at the moment. But when it's raining heavily, it would also supply water from all different places along the way, from the mountains and the bottom, right? Which are basically connected to Himalayan mountains, essentially. And, or Hindu Kush and other mountains. I forget all the mountains' name, okay? But essentially, this is done through force of gravitation. From the higher level of mountains, water flowing down to rivers that are lower levels, right? So we human learn from that. And so, but at the same time, we want to get more water. We want to direct the water to particular places, and that the nature was not giving to us. So that's how the system really developed. So here is the same thing, Qanat system, showing a different components, parts of it, and you can read it later as storage, aquifer, source, uh, where the water line is, the shaft, and then ultimately the most important is the horizontal, slowly declining tunnel that is dig uh, that supplies, as you see on the right side. I'm sorry, left side. You see trees standing, and that would mean that these are used for agricultural purposes. The other reason why that I'm using examples from the Islamic world is because and also in Iran and Afghanistan, Syria, Iraq, and Saudi or UAE. Uh, these are regions that, or Turkey, where a lot of these uh, uh, Qanat system were used, made, found later, is that because this was an area that is comparably dry area with many spaces of deserts. It's really actually not that different from Southern California, actually, similar in this sense. And among them, you have oases, and that's where people live. And so they really are very, very, let's say, overly, water was very overly more important to them than elsewhere, let's say, maybe in tropical areas with abundant water sources or and so on. So that it was natural in the human to develop system engineers uh, to get more efficient to much limited water source than elsewhere. Therefore, that was the place where this kind of engineering and ingenuity developed. And many claim that the origin of Qanat system is actually current Iran or in the past Persia, right? And the reason why they developed the system was because the excessive heat and dryness of their climate causes excessive evaporation. So to keep it minimal, it makes sense to to keep the water underground. And this is very important because by keeping the water underground, the underground temperature being much lower than above ground temperature of anywhere in the world, that the water temperature, the coolness in our class, in our project, is the fundamental dynamics or reasons or purposes to use to cool the city down. Okay. And that is the name of this course and name of the project Cool City comes from. So in our case, in contemporary scene in this project, it's not necessary yet we're using this water from the ground to farm or to drink or to use for other industrial purposes. But actually, the course is going to explore how this could be used rather cool urban spaces and urban environments. Okay, that's very important. And as you can see in this picture, in Iran, people built tremendous amount of these Qanat system. In fact, in Afghanistan, they say that there may be more than 30,000 kilometers, which would be about 20,000 miles, and maybe 10 thousands of these, more than tens of thousands of Qanats in Afghanistan, varying with varying length. Some could be, most of them are less than, let's say, 5 miles long, but some could be hundreds of miles long. And it's almost like a road system today that we use, except these are for water, not to move cars or us, transport us, but to transport water from one place to another. As you can see here in this image, that is basically running under agricultural field. So the water was used for that exact purposes. Otherwise, you can grow nothing here, especially in arid environments like in Iran. And you see these pictures even today, that still in completely in arid region, dry region, look like desert. There's nothing growing on it. You see a small village on the right side that you can hardly make up. But this Qanat probably went to that little village. It's like, what's the animal in your yard or golf course that lives underneath, builds the tunnels, and then build a shaft and lives this kind of dirt mound everywhere that you want to kill to have your perfect lawn? It's kind of like that. Thank you for those people that's still with me in this lecture, the diehards. Don't worry, I won't accuse you of being Bruce Willis or something like that. And here in Istanbul, Turkey, which is one of the most beautiful, great city, like Rome, because it was the center of the Byzantine Empire and Ottoman Empire, there is a Roman aqueduct that goes right across the modern city, which I have seen it myself. And this is continuation of bringing water to this place, which used to be much, much smaller city from 2,000 years ago. And that not only that aqueduct that carries water, but before then, another bridge aqueduct that spans a river. And on the map, you see that as a blue pin at the upper left area of the map that you see. And then the yellow O is where I personally located where this aqueduct is. It was not on the map, but I know where it is. And so these are tremendous construction. The first one was a Roman Empire built it. This one was built, it's called as Aqueduct of Justinian, which is a Roman Empire, but that's wrong title. This aqueduct, I mean, this bridge was completely built by the Ottoman Empire. Then I'm showing you another image. This is an image of a structure in a village in Rajasthan, India, and it's a step wells, a construction made of series of steps that go down into hole. As you can see at the bottom, there is a green, which looks kind of terrible right now, but probably was not like that before. Water. It's a well. So it's a well that people could step down, and this could rise and fall, so that at every level that you could have people all around it gather water and use the water, and this kind of a giant hole accessible, open to the outside. You find this or similar kind of construction from ancient period in India. So you could imagine maybe in Napoli or in Seoul, South Korea, there are two sites of your projects in which in the second half before you begin to design, you will actually get images of the site. I will give you the sites to work on, exact site to work on. You could imagine maybe something like this could be built there. As you can see, another example here that is still being maybe in somewhat use is also in India, part of the great builders under the Mughal Empire and the northwest India, an Islamic empire conqueror that moved into India from Central Asia under the leadership of Babur, B-A-B-U-R. You can type that into your Wikipedia and find out who that is. But they built some great palaces and great architectural monuments. And again, the structures for water resources was one of them. Although in this case, it has Hindu structural elements. So, and then this is amazing, another example of what it means to be an oasis, a historical green oasis in the region of Kerman in Iran. And in this desert area, barren area, there is water underneath. Okay. And that's where people settled. A small village formed, small town formed, even a large city developed. And you can see this kind of isolated green environment that relies on. In fact, Southern California, we live right now, is actually a larger version of this. The trees that we see, the grass we see, they were not here before. Southern California looked more like dry area around this image. How did it become so green? Because we brought water to here, as you know. So in the scale of the oasis is grown to tremendous size, not like this kind of contained, distinctive territory that you see in this image. But in the middle of this image is a long axis of double row of trees. In between is long channels of that pools of water that slowly descends from the building, the gate you see, and then downward. Okay, and maybe the source of water is underneath this building or the rounded pool that you see in front of the building at the bottom picture. I don't really know, but it's not that much different than one example of an ancient painting that from I think around 1700, not ancient, but around then, that Mr. Valentino showed before, where they built the building on top of a well, and then they developed a kind of pool and garden in front of that building for the water to be used and available to its citizens. This is a very much similar case. And in this picture, you see that the water from the building or behind the building or under the building is channeled through use of gravities to go down on this kind of terrace-like structure in which the water was used to grow, let's say, all the vegetation around it, but at the same time used to cool this entire garden. much cooler than surrounding hot desert-like area that you saw in previous picture. And from inside the building, you have this wonderful access to the descending terrace of water, or actually coming to you in this case. And the architecture and the space is connected to, in fact, if you stood in this opening inside this building, you may see a rush of cold air coming through this opening from the garden, from the water, into the building. In other words, it is natural air conditioning, okay? Which air conditioning system is one of the great pollutants of air today. So another one is, it is another city in Tabriz in Iran, which is actually northwest part of Iran near Azerbaijan, near Caucasus Mountains. And there's Al Golu Garden here. And in the middle of a very huge city now. And then you see the mountains around it. It's very dry. There's no trees that you can see, right? How a city like this size can exist in such arid environment? Well, because there's water underground, or water is brought to it from somewhere else. And this was constructed, the garden, and is one of the only surviving historical gardens in the city of Tabriz, which had more than 10 large famous gardens from ancient period. And this is one of the, probably the latest or the newest in the history of gardens in the city. And it was built by the governor of Iran. He restored the pool, constructed two-story building in the middle of the pool that was used for his as a summer house. And you see the image of it in 1921, and compared to this image, and there was hardly any buildings around it, where now you see this image. You see the mountains immediately behind the city, the first mountain range in this picture is the same mountain range that you see over in this picture. And in between that, there's almost no city. It's like a village. And as again, you see there's an axis. Maybe the source of water is underneath the pool. And then the blue axis you see is actually a axis of water pool that goes, actually comes from somewhere else. You'll see in the next picture. And again, it's a terrace system. Again, that water comes down using force of gravity and toward the building in the middle of the pool. Same thing, same system, showing that source of water first serving the drinking water for the people in the village. As you can see, a building called Qasar, maybe that's the name of the village. Water table is underneath throughout. And then once the water, fresh water is for drinking water, then it goes to for agricultural uses. And then it goes down to maybe a river or creek or something like that. But it's important to notice that that it's good idea to have a town before the farm, because if the farm is before the town, then the water being used through agriculture would get polluted, and you don't want to drink the polluted water. So there is a necessary procession in the way the water would be used. The last picture that I want to show you for you to think about is that how, and I'm going to maybe show you more what I mean by the wind tower. This may end up being the starting picture of my next lecture, which would be that you see the Qanats system that takes water from one place to another at the bottom. And then the shaft that was used to access to the tunnel, to build the tunnel, to maintain the tunnel, is also a way that hot air gets pulled down by natural force of circulation from movement from where hot air moves toward, I think, the cold air, or cold air moves to, maybe they do both. I don't know. I'm not an expert on that. That's what you need to research. So the hot air from the ground, above the ground, an arid climate like in Iran, is pulled down by the cold temperature underground. It goes down to the Qanat, and as it moves along cold water underground, the air gets cooled. Then it's brought up to a basement that is captured this cold air, kind of like a cistern that captures water. And then in Islamic world, like in Iran, you see a lot of old buildings with kind of towers built into their buildings and houses. That rises very high. And the reason for that is that it pulls air from the ground up and takes it out of the building. This was a very effective traditional way how people in a desert area like Iran survived for millenniums. Today, of course, we do all this with air conditioning, which produces tremendous CO2, and the chemicals used to air conditioning is highly toxic, not to mention the energy that we use to run them through fossil fuel that are pollutants. So I want to end this lecture with this and make you think about it. This is one of the systems that we could use in your design in the second half of this course. So thank you very much. Anybody have any questions? Do it now. Anybody have any questions? No? God bless you. God bless you. God bless America, the new banana republic of the world. Let me see what I have here. Okay, then otherwise, I see you next week, and I will send you assignment in the next 2 days. Okay, thank you. Bye-bye. Thank you, Jessica. Thank you, Alistair. Thank you for the Die Hard group, Jasmine, and see you next week. Bye-bye.